This is a brief introduction to the structure of hypothesis testing, which will lead us into a more formal structure, which we'll cover in the next video, start covering in the next video. First of all, what I'm going to do is share the document, our chapter 8 notes. And I want you to look at the top here. The statement that is called the Rare Event Rule for Inferential Statistics. And it's the basis of pretty much all the hypothesis testing that we're going to do. And here's what it reads. I'm going to read it carefully, and we'll talk about it as I read through it. If under a given assumption, okay, we're going to be making an assumption, the probability of a particular observed event. So we've made an assumption about, say, a population, and in particular, it would probably be a parameter in a population. And we collect some data and we come up with a statistic, which would be called our observed event. And if the particular observed event is extremely small, based on our assumption, we conclude that the assumption is probably not correct. So I'm going to use an example to talk about this. And let's see what we've got here. We've got a population. And remember, in populations have parameters. We've talked about parameters like the mean, the average of the population, sigma, the standard deviation of the population. And we talked about in chapter 5, P, the proportion of successes in the population. So we get a binomial population, so to speak, where everybody gives either one or two, gives a choice of one or two things. We're going to be talking about the parameter P, proportion. So here's an example. The governor claims that in this population, no more than 30% of the population currently has the new required ID for travel. So he's making a claim here that his claim is that no more than 30% of the population has the proper ID. We can write that in inequality notation by saying the parameter, which he's talking about, 30%, would be a parameter proportion, P. No more than means less than or equal to. 30% as a decimal is 0.30. So we've got a claim from the governor. Now, we may not agree with that claim, and if we don't agree and we're worried about his claim, we're going to conduct a test to determine if we think his claim is valid. So what we're going to do here is collect a sample from the population, and our sample consists of 20 randomly selected people. And out of that 20, we end up with 10 successes, a success being they have the correct ID. So what does, now we got to figure out is, does this information here, these 10 successes out of 20, support this or not? Okay, does it support that or not? So I'm going to switch over to the calculator, switch over to this, and we see that this is the distribution of the binomial probabilities, or the binomial random variable with the height of the rectangles being the probability. And it starts at 0 here, and 1, 2, and so on. The probabilities start getting bigger, then they start coming back down. It's a normal shaped curve until we get out here. This tail right here goes all the way out to here. So it's skewed, so it really isn't normal. because we've got all of these values out here with very, very little probability. But anyway, so we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, actually, this is 9. This is 10 right here. And then it's 11 and 12, etc., up to 20. Now, when we talk about, remember in chapter 5, when we talk about unlikely outcomes, is the 10 that we observed an unlikely value? The definition for unlikely is if X is unlikely, then the probability of X or more, in other words, at least X, if that probability is small, less than or equal to 0.05 was the example for unlikely. We could change that number, by the way, to anything, and we will, in future hypothesis tests, have different values for that unlikely. Then we need to find out what the probability is for having 10 or more successes here. If it is less than or equal to 0.05, if we use 0.05, then we're going to say that it is unlikely, and therefore it doesn't match what we would see in our claim, from our claim, okay? So let's go back here and let's find out what is X unlikely. So we want to know, is the probability of X being greater than or equal to 10, is that less than or equal to 0.05? So we could find the probability of 10 plus the probability of 11 all the way up to the probability of 20. And we find out that it is the probability that X greater than or equal to, question mark, 10 is equal to 0.0480. Okay, so this is less than or equal to 0.05. Therefore, since this is unlikely, if X or more is unlikely, then we'll reject our claim. We'll reject our assumption. And that's the basis of what we're doing here. That's the kind of thing we're going to be doing in hypothesis testing. We're going to make a claim about a population parameter. We're going to collect data. We're going to see if that data matches what we would expect from the claim or not. And if it doesn't, we're going to reject the claim or the assumption that we have about the parameter. Okay, so let's see how we're going to start our structure here. Let me go back over to sharing the, well, unshare. I don't want to share, actually. So I'm going to close that. What I'm going to do here is list what we're going to have in the structure of our hypothesis test. Let me erase this right here. So what we're going to do is in the first step, call it step 1, we're going to identify the claim and develop hypotheses to test and identify the unlikely value and we'll call this thing alpha. It's a Greek letter alpha, A-L-P-H-A. It's the Greek, it's lowercase Greek a. Step 2, we'll collect sample data and calculate a statistic that we know the distribution of and we can make probability statements about. And then step 3, we'll assess the statistic relative to the assumption. Okay, step 4, we'll reject the assumption if the statistic is unlikely or fail to reject if the statistic is not unlikely. And then finally, step 5, we'll write a conclusion. In the next video, we're going to flesh these out. All 5 of these things, we'll flesh them out. We're going to have quite a bit of work up here identifying the claim and the hypothesis. And then this is going to be relatively simple in the sense that we're going to have known formulas to work with to calculate our statistic, and we'll talk about each one of those. And then we'll figure out there are 2 main ways and a third less used way to determine if the value of the test statistic is unlikely or not. And then this step 4 is going to be really straightforward and really short, because if we determine that it is unlikely, we're just going to say that we're rejecting the assumption or failing to reject the assumption. And finally, this is very simple too. We're going to write a conclusion, and we pretty much are going to have canned words for this. We just have to make sure that we've got the right set of words. So that is what we're going to be doing in the next video. So I will leave you from here. Where are we going?